A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students of 12th class subject Botany, Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, you know we are discussing the laws of these principles of inheritance or Mendels laws, and you know that Mendel, while experimenting the pea plant in his garden, which is situated in the monastery, and he has given 3 laws about the genetics, and those 3 laws I have told you. The first law is the law of dominance, which we have discussed in our previous lecture, and the second law is the law of segregation, while as the third law is called the law of independent assortment. Now today we will throw light upon the second law of Mendel, which is called the law of segregation. This is also the principles of inheritance law of segregation. Now regarding this law of segregation, according to this law, when a pair of contrasting factors or allelomorphic genes are brought together in a hybrid, these factors do not blend or mix up, but simply associate themselves and remain together and separate at the time of gamete formation. This law can be explained by monohybrid cross. So dear students, this is the definition of second law of segregation, that when a pair of contrasting factors or allelomorphic genes are brought together in a hybrid, these factors do not blend or mix up, but simply associate themselves and remain together and separate at the time of gamete formation. And this law has been explained by Mendel by taking the monohybrid cross. So the explanation of this law is, when a pure tall pea plant represented by T is crossed with a dwarf plant that is represented by t, then all the progeny in F1 generation are tall. So dear students, you should remember here that when the pure tall pea plant, which is denoted by T, when it is crossed with dwarf plant represented by t, all the offspring in F1 generation are tall, but can carry both T and t after fertilization. So dear students, when a pure tall pea plant denoted by T is crossed with a dwarf pea plant denoted by t, all the progeny in F1 generation are tall but can carry both T and t after fertilization. The gametes of F1 progeny undergoes meiosis. Some of gametes have T and some have t. These factors retain their individuality and do not become mixed in a hybrid, which is also known as purity of gametes. So dear students, you should remember that this second law of segregation is also called the law of purity of gametes. On the basis of his experiments, Mendel concluded that contrasting traits as tall and dwarf sizes in peas are determined by some factors that is transmitted from parents to offspring in sex cells or gametes. So, on the basis of experiments conducted by Mendel, he concluded that contrasting traits as tall and dwarf sizes in peas are determined by some factors that is transmitted from parents to offspring in sex cells or gametes. This Mendelian factor is now called a gene. So, dear students, today we have completed half of the subject matter of this law of segregation. It is not completed yet, it is continued, but today we will stop here and we will move ahead in our next lecture tomorrow, inshallah. So, you should here remember that how the Mendel has proposed or given this law of segregation, and today we have thrown light upon this definition and a short statement or experiment which he has conducted on the pea plants, and on the basis of this experiment he conducted that contrasting traits as tall and dwarf sizes in peas are determined by some factors that is transmitted from parents to offspring in sex cells or gametes. This Mendelian factor is now called a gene. So today we will conclude our today's topic. In our next lecture, we will move towards the other part of this law of segregation. And till tomorrow, stay home, stay safe. Thank you very much.